In these videos, I'm covering section 4.5, which is on exponential and logarithmic equations. For example, we want to solve, give an exact answer and a decimal approximation rounded to 4 decimal places, but we're only going to do the rounding if necessary. Example number 1 is 2 to the x minus 2 equals 1 over 128. So there are going to be a few different types of exponential equations. The first thing that you need to know is what makes it an exponential equation. So exponential or logarithmic. Let me try that again, because that was terrible on my spacing. So exponential or logarithmic. So what makes it one or the other? Exponential means that we have an x in our exponent. Logarithmic, I would say, is very obvious because there's actually a log in the equation. So exponential has an x in the exponent. Logarithmic has a log in the equation. So again, I would say that logarithmic are a little easier to spot, but you first need to decide, am I dealing with an exponential or a logarithmic? What classifies it as exponential? What classifies it as logarithmic? And then solve accordingly. Okay, so example number 1, and really all of these first few examples are going to be exponential. But again, on the test, eventually they're going to be jumbled, and you need to be able to decipher through. So there are going to be 2 types of exponential equations that have 2 different ways to solve them each. So exponential equations, or to solve exponential equations, type 1 has one x, only one guy with x in his exponent. So type 1, only one guy with x in his exponent. And if we are this type, our first step is to get the guy with x in his exponent all by itself. Get the guy with x in his exponent. All by itself. Next, once you have the guy with x in his exponent all by itself, step 2, can I write both sides in the same base? Can I write both sides in the same base? Sometimes the answer, can I write both sides in the same base? Sometimes the answer to that question will be yes. Sometimes the answer to that question will be no. If yes, write both sides in the same base, equate the exponents, finish solving. If yes, do it. Equate the exponents. Equate the exponents. Finish solving. If no, then we'll have something different to do. Okay, so example number 1, 2 to the x minus 2 equals 1 over 128. The first thing that you have to ask yourself, is he exponential or logarithmic? He is exponential. Again, these ones are a little trickier, not as easy to identify as logarithmic, but he's exponential if there is an x in his exponent. And he is type 1 if only one guy has x in his exponent. My vote is I only see one guy with x in his exponent, and that guy is 2 here. And so next, we want to get the guy with x in his exponent all by itself. That's already done for us here. Check. Once we have him all by itself, can I write both sides in the same base? Meaning that, is 128 a power of 2? My vote is yes. So this is 2 to the x minus 2 is equal to, first of all, if it's 1 over a power of 2, that means that my power of 2 is a negative. And fiddling around on your calculator, you can find that 2 to the 7th is who gives us 128. And once I've written both sides in the same base, then I equate the exponents. So x minus 2 equals negative 7. And finish solving for x, plus 2 to get that x equals negative 5. Solution set, negative 5. And we are all done here. Hopefully, oh yep, it moved everyone, that's good. All right. Solution set, negative 5. That negative is a little weird, but we are done here. Now, example number 2. Again, he's exponential because there is an x in his exponent. He is type 1 because there's only one guy in the equation with x in his exponent. Eventually, there will be more than one guy with x in his exponent. This, however, is not that case. Okay, next. Get the guy with x in his exponent all by itself, and he's already all by himself on one side of the equal sign. There's nobody being multiplied onto him or added or subtracted on the same side as him, which is why he's already all by himself. Next thing, can I write both sides in the same base? What I'm asking myself is 47 a power of 2? My vote is that 47 is not a power of 2. And so this writing both sides in the same base only works for a very limited number of numbers on the other side, right? Because powers of 2 are like 2, well, it's 1, then 2, 4, 8, 16, 32, 64, 128, 256. I could keep going, but there are lots of numbers in between there that we skip. And then the question is, well, how do I solve for x when he is trapped up here in the exponent? And the way that we solve for x when he is trapped up in the exponent is that if no, you are going to log base b both sides. If no, log base b both sides of the equal sign. So log base b both sides of the equal sign. Why are we going to log base b? Because logs and exponentials are opposite operations like plus, minus, multiply, divide, squared, and square root. A logarithm undoes an exponential. Now, we are log base b is going to change every single time. In this case, our base is 2, so we're going to log base 2 to the x minus 2, which is going to equal log base 2 of 47. Why are we log base 2ing? Because log base 2 of a base 2 exponential cancels out. Log base 2 of 2 to the x minus 2, log base 2 of 2 cancels, and x minus 2 falls out. That's going to equal log base 2 of 47. And then I can finish solving for x. Finish solving for x. Finish solving for x. Doesn't have to be x, but x is our favorite letter. Oops, I did not mean to write a number for. I meant to write the word for. Trippin'. Finish solving for x, and then there's going to be one more little step. Okay, so next I'm going to plus 2, plus 2. Side note, plus 2 outside cannot magically move inside of a logarithm. And so x is equal to log base 2 of 47 plus 2. And this is our exact answer. I just put the parentheses on 47 to show you that the plus 2 is not inside of there. Do you have to have the parentheses here? No, not really, but I just want to make sure everybody's on the same page. And again, this is our exact answer. We do not touch our calculator until the very end. But the problem here is that log base 2 is not a button on our calculator. And so how are we supposed to get a decimal approximation? It's what the handy dandy change of base formula is for. To type this in my calculator, I need to switch him to both ln or both log. Why are we going to pick ln? We're going to pick ln because he's a button on our calculator and because I said you need to. So this is ln of 47 divided by ln of 2 plus 2. This is what you will be typing in your calculator. So finish solving for x. Use the change of base formula. If necessary. If when we got done with our problem, this wasn't a log base 2, but just a log, like a log base 10, or if he was in fact an ln Could that be the case? Absolutely. We won't always need to use the change of base formula, but in this case, log base 2 is not a button on our calculator. So use the change of base formula if necessary to get decimal approximation. Last thing that I want you to know, this is not how the book does these problems. The book does the problems a different way. If you view an example in these homework problems, it will probably confuse you. Slash, you need to do it my way because A, my way is better, and B, because it's the only way for you to get full credit on your test. Okay, so I'm going to type ln of 47 divided by ln of 2 again, and then plus 2 to that. Make sure you know how to work your own calculator. I got that x is approximately 7.5546. 554. There's a 5 in the fourth place, but the 8 next door is telling him to go up to a 6. Now, this one and this one that I had originally circled are technically both exact answers. This orange one that I typed in my calculator is going to be kind of what the book's answer looks like. There may be a common denominator with the 2 and the ln of 47 divided by the ln of 2. But again, this is what the book's answer is going to look like. This is what your answer needs to look like. You don't... I lied. You do have to. Since this is take home everything, you do have to write this step on your paper. If it was in class, I wouldn't make you write the orange step on your paper showing me the change of base formula that you use to type it in your calculator. But I do need to see all 3 of these things on your paper for you to get full credit. Log base being both sides is not usually how algebra books do this. Log base being both sides, I've had more success with students doing it correctly. If you start to understand and remember that what's the opposite of an exponential? A logarithm. What's the opposite of a logarithm? An exponential. My way is better. You need to follow my directions when you take the take-home quiz and the final. Okay, I'm going to pause my video and then we'll do example number 3.